Hello, so in this video I'll be talking about how I cascaded a 1-bit parity to make an 8-bit comparator in Vivado. After creating the design source under project manager bar and adding sources right here, there should be a text editor file that pops up, and you can see here at the top that there is a time scale, and it indicates that there is 1 nanosecond for every lap. And on line 23, we have our 1-bit parity module with some parameters. Input A, input B, output X, and we have a SOR gate with output X and input A and B. There's also an module, and in the same design source, we make another module, even 8P. This is for our 8-bit comparator. We have our input indicating that there are 8 bits right here, and there's an output P. We have our wires, which would be the output for each gate. We have P0, P1, P2, P3, P4, P5. And then I called the module even 2P and cascaded it 7 times here. As you can see, 7 times, and mapped the ports right here. And we have our end module. From here, we generate the circuit by clicking on schematic in the RTL analysis bar right here, schematic, and we should have this circuit. We can press the addition sign to open up our gates. And as you can see, we have our 7 1-bit comparators. That includes 7 SOR gates, and we also have our output right here. Here are our 8 bits, 0 to 7, which would be the MSB and LSB. And now, moving on to the timing diagram, you would have to create a simulation source. So you go under project manager bar, you add source, add simulation source. You should have this text editor right here. And you would have to declare registers and wires. So we have 8 bits right here. We have wire Y. And then we mapped module even 8P with unit under table. Here are the ports that we mapped. We mapped the design source with a simulation source right here. And then I declared I for the upcoming loop. We have the initial, begin, and a display right here. For our bit names, we have the for loop right here, and it's iterated 16 times. This is in hexadecimal, by the way. And we have the begin. We declared A to I. We have a delay of 10 nanoseconds. And then we have the display. This displays our bit values. We have the end for the for loop. We have a 10-second delay. We have finish and end for the initial. And we have an end module. So you can see that we would have to run simulation, run behavioral simulation, and this timing diagram should pop up. You can see here these are the hex values, nanoseconds up here. We have some outputs, zeros and ones. And so today in this video, I learned how to call a module multiple times and cascade it a 1-bit parity to make an 8-bit comparator. Thank you for watching.